Good evening to all. I'm Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS, Rajalakshmi College of Arts and Science. Today I continue my topic is agent fog computing. Um, Today we are discuss about in fog computing. The last class we are discussed about what is the edge computing. Today we are discuss about in fog computing and extending the cloud to the edge. So this is a comprehensive introduction of fog computing. Today's is interconnection world in the billions of IoT devices to generated from some unpredicted volume of data. Traditionally, we have using the cloud models and some significant limitation. And the fog computing is very emergence of crucial of paradigm because of the bridging the gap between data sources and network edge to the front of cloud data centers. So this presentation of fog computing exponents of origins and critical addresses the different related paradigm and agent cloud computing and it is a key features we have including the benefits of fog computing. So some technology and devices we have using the fog. So edge and cloud the center of the fog computing. So today is discuss about what is the origin and concept of fog computing. First, Cisco Vision is one of the computing for computing. It was developed by 2012 Cisco and introduced the accelerating of posted by the Ford proliferation of IoT devices and massive data volume the generate and bridging the gap of for computing. The developed was to crucial intermediary layer and design the bridge and functional and it is a geographical gap between resources of constrained edge devices and powerful but the often distant of cloud data centers. Distributed processing it is for computing it's a shift computation of storage and networking services closer to the data sources and it is rather than sending all the raw data directly to the cloud. So decentralized nodes there is a focus of utilizing geographically dispersed of decentralized node such as industry controllers and smart cameras and routers and perform the preliminary of data processing and analysis. And a need for fog computing, addressing high latency and improving data security and mitigating network bandwidth and supporting the offline operations and addressing the high latency real-time applications such as autonomous vehicles and remote surgery. Even though slightly delay can easily weaken critical consequences and improving the data security is sensitive information locally at the fog a layer in the inherently of enhanced data security and mitigating a network bandwidth. It is a billions of IoT devices generation of vast amount of raw data. So easy we can transmission of all the to the cloud with overflow of network bandwidth. So supporting all offline operations. The fog computing is enables of rapid decision making and continuous operations even though cloud and connectivity of intermediate of unavailable. So what is the major difference between fog, edge, and cloud computing? Cloud computing is reference of centralized data centers offering the global reach for all the massive computing power, and fog computing is acts of intermediate layer. So it is a compromising the distributed network, and easily we can closer to the data sources than cloud and further data edge devices. And edge computing is processing of data directly because of the decentralized process. Easily we can gateway of very closed. So data it should be the generation point is needed from the edge computing. Some key features of fog computing it is a proximity and low latency and geographic distribution and interoperability and heterogeneity. And the proximity is it is a the strategically the position of near end user and IoT devices, the ensuring the data processing occurs close to the source are possible, and geographic distribution like the unlike centralized cloud data centers. The fog computing nodes is designed to be widely dispersed of across various geographical locations, and low latency is like performing of closer to data source. The fog computing is enabled the ultra low latency we, we are using, and interoperability is, which means it is ensures that all the data interaction and communication between different fog nodes. Heterogeneity is the future of fog computing because of ability to support and diverse range of hardware and platform and operating system. The benefits of using the fog computing and the cost efficiency is 30% and reduce latency is 90% and bandwidth optimization is 50% and enhance the security is 75% and improve the reliability is 80%. For computing is the overflow. Data ingestion is one of the IoT device sensor, cameras and smart meters. Easy we can generating for all the new data from operation environment, and local processing routed by the local nodes. We are using the fog nodes, and easily we can analyzing and filtering for all the data, and pre-processing the tasks are performed, and data aggregation is data processed from the multiple individual edge sources in then aggregated at the fog layer. The cloud integration, which means it is a pre-analytical aggregated subsequent and send the decentralized cloud for deeper insights. Technology enabling fog, Internet of Things, IoT and virtualization and artificial intelligence and 5G connectivity and message queuing, telemetry transport. They are technology in enabling fog. Industry using fog computing in smart cities is 50% because of real-time traffic management system using fog computing at capacity of 15% and a reduction of traffic congestion through the adaptive signal control the smart packing solution. And the 20% of manufacturing industry 4.0, the predictive the maintenance and power by the fog analytics prevents of 20% and unscheduled scheduled downtime in factories and identify the equipment failures before they occur. Future trends in fog computing is edge at the edge, AI at the edge, and 5G integration. The 5G integration will deepen, providing even more supporting from the ultra latency operation, high bandwidth communication, and essential for demanding of edge applications. Thank you.